Let's imagine you're in a situation where the probability of success, at least for now, is fixed, and therefore the probability of failure is fixed. And you're asking yourself, how many times am I going to have to try before I succeed next? Well, with fixed probabilities of success and failure, the geometric distribution is exactly the tool that you want to use. Head on up Lines on Clay users to File, make a copy, and plunk around with this spreadsheet that we've put together for you to get a sense as to how this works. What you're going to want to do is in column A, we're basically saying, hey, well, maybe you'd have to go 5 times before you achieved your next success, or maybe you'd have to go 9 times before you achieved your next success. You get the idea. That's what column A is all about. Column B, the probability mass function, is telling you the corresponding probability that, yeah, if you have a 50% chance of success and a 50% chance of failure, there is a 0.0078125 chance that you will not achieve success until the 7th try. Or there is a 0.125 chance that you will not achieve your next success until the 3rd try. The CMF column, as it always does, just adds up the values that we've seen in the PMF column so far. So for instance, 0.5 plus 0.25 is 0.75. Well, if we add 0.125 to that, we get 0.875. You get the idea. So the CMF is moving higher and higher gradually towards 1. This visual over here shows the PMF, and the PMF is always falling towards 0. An analogy to tossing a fair coin would be a great intuition builder. Let's imagine that flipping heads is success and flipping tails is failure. Well, what we would think is like, yeah, it gets harder and harder to have to flip the coin many times before you see heads again, right? Because what that would mean is that you would have a very long string of tails that would be up front, and then finally the experiment stops as soon as you flip that first head. Well, the probability of flipping heads the first time is 50%. And then the second time, it's 25%. And then the time after that, it's, a half of 25%. So 0.125. All geometric distributions have this property where they start high and then they gradually move lower towards 0. We also created this visual for your benefit that has the PMF on the left side and then has the CMF on the right side moving up towards 1. Again, we kind of stopped arbitrarily, but we stopped at 40 trials. So what we want you to do is go in and kind of plunk around here, and all you have to do is change this one value, this probability of success value. That's what we would call the parameter, the one parameter of the geometric distribution. Later, we'll show you some cool things like you can use that one parameter to derive the expected value or the standard deviation that one would expect if they were to repeat this experiment many times, how long they would have to wait. So great, go on in there and have some fun. The last thing I want to show you is that if we take our probability lower, say I'm going to make this like 11%, it's the same basic shape, right? That hasn't changed. This has the same dynamic going on as it did before, but I think you can agree it's more gentle, it's more gradual, and that's always going to be the case whenever your probability of success moves lower towards 0.